Namaskar, my dear friends. Let us talk about how we can design a circuit to switch the input power to the system load. Okay. So what we'll be doing is we'll be using two MOSFETs. One will be P MOSFET and one will be either N MOSFET or NPN transistor, so that we can drive that particular MOSFET to switch on the system load. Okay. So as you can see, a very simple circuit that is actually designed for this purpose. You can see we have a input power supply here, let us say 12-volt battery or 20-volt battery, anything. So this is from your battery supply or main power supply. Now your aim is to not connect this power supply directly to this system at this place. So this is, let us say, my load. Now what happens is whenever the system is switched off, you want it to be disconnected. So that's the reason this is a P channel MOSFET. So this is my PMOS, okay, which is helping you to disconnect the input power supply to the system load always. So what happens is, let us say you are going to use one MOSFET here, and let's say N channel MOSFET, and this is my drain, this is my gate, this is my source. Now what is going to happen is your microcontroller can send an enable signal here. So I am going to put a pulse wave here for simplicity. So this is my MCU GPIO, okay, or some enable signal which will be enabling this. So once you enable this, what will happen? This particular gate will be energized and this MOSFET will switch on. Once this once this NMOS will switch on, what will happen is it will pull down the gate of this PMOS, and since this gate will be pulled down, the power will be transferred from input to output. Okay, so this is how the high side switching is achieved. So as you can see from the graph itself, like we have input voltage which is continuously 12 volt, okay, and we have enable signal which is this color. So whenever my enable signal is high, my output is 12 volt. So this is my V out, okay. So if you want to keep your output always high, you have to keep this enable signal always high. That's all. Whenever you want to switch off the input to the output, what will happen is you will switch off the enable signal, that is make it low, and it will come down to 0. So why don't we do one thing? We will analyze this circuit and try to understand how to do that. So let us open LTSpice. I have quickly put all the circuits here. So put V for like voltage, R for resistor, C for capacitor, all these things you can do, G for ground. Like to put some components, what you can do is go to this component list and type here PMOS, okay. So here you can see PMOS is there. Understood. Then similar to that, you can write down NMOS to get NMOS. So like that you can put and press W to wire it up, okay. So like that you can do. So I'm going to remove all of this. I don't need right now, okay. So anyway, the circuit is complete. What we have done is we have an input voltage here, we have one PMOS, and we have the output load I have connected for simplicity. Now I am going to change this particular like source. Let us say right click it and see I have put it in pulse 1, and we have a V initial 0, V on 3.3 volt. Rise time and fall time I have kept 1 microsecond, that is not a problem, and T on and T off I have kept it 100 millisecond and 300 millisecond. If you want I can keep it like half both. So 200 millisecond high to 200 millisecond time period. Okay. Now let us run it. So once we run it, what is going to happen is, let us say this is my input voltage which is 28 volt. Okay. If you want I can reduce the voltage, but right now we'll see that. And this is my output voltage which is going to be the green color one. Whenever my input voltage is high, you will see the enable signal was high. Okay. So whenever my enable signal red color is high, my output is going high. And whenever my enable signal is low, my input is going low. So I'll just remove that part. Then when you will see properly. I'll just double click here and then let's say enable signal. So you can see very nicely, whenever my enable signal is high, my output is high, which is V out, green color, and the blue color, whenever it goes low, my output is low. So this is achieved by a simple low cost, like N MOSFET here, and this will be high power P MOSFET because it will have to carry a high amount of current. Now the same thing can be achieved by putting a transistor at this location. Okay, so what will you do for that? You can put a transistor, very simple transistor here, and same way this place it will get connected here, and this one it will get connected at this location, and this is grounded. Okay, so you can use, let's say, BS 138. Okay, so BSS 138 you can use. Understood? All right, guys. So if you have any questions or any understanding that is needed for this particular, like switching of your power supply from input to the system load by utilizing a MOSFET or a transistor, you can put down your queries in the comment box, and we shall be able to answer you out. So hope you have a good understanding about it. Now, if you want to, like vary your battery voltage, let us say quickly vary, let us say 12 volt it is. So 12 volt input battery, your output will also be 12 volt. So let us run and see. So you can see output is 12 volt. This is continuous output 12 volt, and whenever there is a need to switch it on, it will go and it will go off. Understood? There is little bit a spike here that is coming, so that can be avoided by putting one capacitor here. So if you want, you can like use one capacitor, simple capacitor here. So just quickly add it here, W, and then add it here like this. Okay, so let us say I'm going to put it uh, 10 nanofarad and then run it. So this spike may go out. Oh, it has increased. Anyway, like designing we can do that way. One more capacitor I can put it at this location. It will be little bit slower. Okay, so let us say I'm going to put 100 nanofarad will be too much, and let us delete that. It's not helping yet here. Now let us run it. Yeah, so you can see the spike is removed. Okay, so let us say what was that? What I told you is you just remove this, and let us run it. Okay, so you are seeing there is a like undershoot that is going at the output. Now if I keep that capacitor, which will help to like charge the PMOS properly and put it in proper situation, then this will be removed. Okay, so alright guys, good. If you do have any queries or any questions, you can put down our queries in the comment box, and we shall be able to answer you out. Thank you.